All right, wonderful people. Welcome to today's presentation of DBA Fundamentals Group. Today, brought to you by the one and only Kellyn. That's right. She has no name, no need for a middle name. Everyone, and the last name, everyone knows her just as Kellyn. Be done with it. Today, we're doing infrastructure DBA in the cloud. It is February 15th, 2022. As you see in the top right-hand corner of my screen, hopefully everybody can see that, is the names of the three people who are leading the DBA Fundamentals group: Steve Cantrell, Shane O'Neill, and myself, Kevin Wilkie. Right beside our names, you'll notice the Twitter handles that each of us go by. If you need to contact us for any reason, please feel free to. That's how you reach us. Right below that, you'll see some of our many reasons to actually, or ways to contact us. First being Meetup, where most of y'all got hold of access to us for today's presentation. Below that is our regular website, dbafund.org, where you can reach out to us and see any past meetings and any future meetings. On that note, if you have any presentations you would like to talk about presenting, just feel free to reach out to us on there. Below that, you'll notice there is dbafundtube.com, the true way of actually having all kinds of fun on YouTube, learning about DBA stuff. That is where all of our DBA past presentations are. If you really want to make sure that you get hold of all our presentations as they're actually uploaded to YouTube, be sure to like and subscribe. We'd appreciate that. Below that is one of our other many ways to get a hold of us, either through Twitter, DBA Fun, Slack, or on LinkedIn. All sessions, as I said earlier, all sessions are recorded and usually will be available within 1 to 2 days. Check us out on dbafundtube.com. And today's presentation is brought to you by Kellyn. And with that, Kellyn, I leave it up to you. Stop sharing so that you can share.
I am going to try to do this. I want to present inside Teams. Let's see if this works. Have you guys tried this yet, presenting inside Teams? I find that it's a 50-50 if it works well.
Look at that. That's about it. It works, though.
Ta-da. So as you see, the name of this session looks a little bit different than what it said in there, but it is the same session. Minding the gap is extremely important to us. I call it the gap because for a lot of us DBAs, knowing infrastructure is a challenge. And just to start this out so you know who I am, my name is Kellyn Gorman, or Kellyn Pot'Vin-Gorman. I've kind of given up on my maiden name because it's a little difficult to pronounce correctly, and I all of a sudden am starting being called Potvin and Vin Pot, and all of a sudden I'm Pol Pot's cousin, so I just say give up on the Pot'Vin. I am known as DBA Kevlar on Twitter, and I have both my email addresses there. I do work for Microsoft as a principal CSA. I'm better known inside Microsoft as just the SME for Oracle. And Azure, we work for a very small team that does Oracle migrations into Azure infrastructure as a service. We are a whale in the pond that most people don't talk about. We thought we had like 3,000 customers. The count was going to come up, and that we had added 1,000. Found out no, they had only counted half of our workloads, only the Oracle Linux. We do about 50% in Red Hat. So found out that we have like 5,000 to 6,000 customers, and that we've moved over 2,000 people in the last year. We're very busy, very, very busy, and I wish we weren't as busy most times. So let's discuss who makes the best DBAs. We know this, we have control issues. I will always say that I'm a DBA, as much as, I have all these different roles, everything from, oh gosh, I've belonged to the CTO as a technical intelligence manager to now a principal CSA. SME on Oracle, I'm always a DBA. It's where I live. I've been a multi-platform DBA for 25 years now. I started out in Oracle and SQL Server. I'm one of those that got my Oracle certification, and they handed me my first database, and it was a 7 terabyte SQL Server 7. It was a nightmare, but boy, did I learn a lot of SQL Server at that point. And then, of course, Oracle came right afterwards. And so I've always been multi-platform and took on MySQL, Postgres, Ingress, Sybase, DB2, MySQL, whatever they had, they threw it at me. And I love database technology, so that's where I've kind of always been. So why do we do infrastructure as a service? Everybody, every cloud platform, doesn't matter if you're talking Azure, or AWS, or OCI, or GCP, they're all talking about their PaaS solutions. PaaS sounds really wonderful, but in a lot of ways, it can't handle a lot of these big workloads, especially like the ones that I'm on, that are on Oracle. It may be because of business SLAs. They're saying, these PaaS solutions can't meet that. The vendor-specific requirements that goes into it only runs on Oracle. It only runs on SQL Server. You find out that, you can't go Postgres. It's not going to happen. And then other ones are, such as myself, it's the platform demand. I have a lot of folks that may come in and say, we're going to put this on hyperscale, and I've got a 6,000 megabytes per second workload. And I'm like, you can only do 100 megs per second. Thanks for playing, turn around and walk back out. It's a challenge for us. So knowing that a lot of PaaS solutions may still be in their infancy, it's not just coming up in features, but that the workload itself can't be handled on some of these PaaS solutions. And my latest DBA Kevlar blog, I go into this, that this is really a battle and really important to comprehend that it's the workload, it's the applications, it's everything connected to the database, not just the database itself that decides if you can go to a PaaS solution either in your platform or going to another platform, replatforming. And I will answer a lot of your questions at the end because I find that I end up answering most of your questions during the session. So please feel free to ask if you'd like, but I most likely will answer them as we go forward. So if you're not on mute, if you have a question, feel free to let me know. I'll be glad to answer it. I heard an intake and breath, so I wasn't sure. So where are we? We're talking about infrastructure as a service. Just to remind you what you're responsible for versus what you're not. And infrastructure as a service, it's everything in that green area is the responsibility of you. Everything in the orange that's inside that red block is responsible of the cloud provider. And that makes a big difference because when you start talking about the virtualization and the servers and the storage and the networking, it's kind of nice to get that off of your plate. Now, we'll also talk about how to simulate a PaaS solution inside infrastructure as a service. There's many ways to do that, adding services on, bringing in some of the tools you may already be using for your on-premises environment to lessen the workload demands for tedious tasks. So we'll also talk about that as well. And then those PaaS services, they're really great for a lot of greenfield projects. As you're going forward and starting to build out something that's going to grow over a period of time, it works really great. Just for me, it's really hard to bring in those robust, large workloads that you've been running since SQL Server 6.5 and 7. You've been running since Oracle, 9i. They're probably going to be less of an option to go into these PaaS solutions. And software as a service only if you want to give up about 60% of your features. Then we'll talk. But that is my reality. That is my experience that I have had working for Microsoft and AWS and OCI. So we'll just kind of roll those all in there too. So what are these benefits of this infrastructure as a service? There's a quicker migration. I have seen slides where they've said, oh, it's going to be years to do a lift and shift. No, it isn't. It is the faster. Migrations into a PaaS solution often take literally years because it's not just the database that you have to migrate. It is the application. It is everything connected to it that you have to look at all of those, identify them, and rewrite them. A lot of coding changes that you're able to keep similar architecture. You're literally using that cloud environment for a new data center, and that makes it quite similar for me. Folks are very surprised when we start building out their architecture inside the cloud. And they're like, so I get to keep this? Especially for my Oracle folks, they're like coming in going, so you're going to put all my Oracle databases on Windows. And, we talk about this, that Windows isn't the problem, it's Oracle, because Oracle has no Windows servers to develop on. So if you're not developing for Windows, you shouldn't be running on Windows. So we know this. But we also introduce those cloud services and features, and this is where we get into more of the lift, shift, evolve of you bring your workloads onto the cloud, and then you start introducing all these services that can get more out of the data than what it was doing on premises. And this is very, very valuable. This automates a lot of things. This brings us into new ways. For a lot of my folks, they may have been using Excel to do a lot of analytics and provide more value. You introduce those Excel folks into like Power BI, and I joke it's the crack of Microsoft, because you show them this and suddenly they're like, oh my gosh, it's the same ribbon that I use in Excel. I can do analytics now. And then we introduce them to some of our machine learning tools. Same thing. They are so comfortable and it's so user-friendly that they can suddenly do more with it. They may load that Oracle database into a data lake and start to get more data value that way. So we start talking about where this brings them. And we also remove them from the data center and buying hardware. Your hardware, as soon as you purchase it, is pretty much dead man walking. It's at that point on a life cycle of where it's going to be, how long it's going to last, 5 years, so on and so forth. Where in the cloud, people can scale up and scale the new hardware. I have a lot of folks that are using like V3s. You'll hear this version numbering in infrastructure, and the new V5s came out at Ignite. And I'm like, go up to the V5s. It's going to have so much I/O with, and it's got more features, and you can get more disks that you can attach to it. These are opportunities that you just scale up and go. So what I laugh about is, this is really the truth. Infrastructure folks that try to lift and shift the infrastructure for database work, this is one of the most important things that you need to consider when you're moving a database workload. People will lift and shift the hardware, not the workload. And data and AI folks, your job is to kind of know that database. We have a gap of infrastructure data specialists that don't exist. And this is where you can come in and really provide value. So why do we migrate the workload instead of the infrastructure? Servers are not sized right often. We don't know how to do capacity planning. You will have workloads that what it requires to run in the cloud or run on any infrastructure is very different than what it's running on. It could have changed over time. People added new code, new applications, new processes. All of this stuff could really add up. The database workload, grew differently than what they thought it was. You think about how we size hardware. People come to us and say, it's time to do a capacity planning. I need you to buy new hardware. It has to last for 3 years. We'll have more money in the budget then. So we size it and we go, well, we're going to pad it a little bit. We don't want anybody at our desk. So we DBA size it out and we give them those numbers. 3 years from now, we come back to our bosses and say, okay, I'm ready for my new hardware, ready to go through our new capacity planning. And the boss says, oh, there's no money in the budget. And we're like, we're all right. We planned on running on that stuff for 7 years. We knew this would happen. So we padded on top of that. So you think about if you brought that infrastructure hardware over to the cloud, it's probably sized wrong. And we find, especially for Oracle, which is so critical to make sure that we're not paying for Oracle licensing where we don't have to, we found 85% of our workloads were missized. We literally save customers millions of dollars by moving the workload, not the old hardware. We leave the hardware. We don't even touch it. And you can do this no matter what database platform this is coming from. SQL Server, Oracle, Postgres, it doesn't matter. MySQL, all of them have the ability to collect this workload information. Now, I have focused on being able to do this for Oracle because that's what they absolutely need me for at Microsoft. But it is essential that you do this and do the same when you're doing no matter what that database platform is. Find out what the database needs to run in Azure. Move that. Do not move the infrastructure it came from because it's most likely wrong. The other thing is to architect for the cloud. Our data centers, for them to build into it what is built in Azure, that would be pretty much impossible. I mean, it's just killer to expect people of that. That's a lot. Also find out how you've been doing things on premises may not be the way you want to do it in the cloud. So somebody says, I am just going to grab this table and bring it over into one database to the other. It's not hard. It takes 2 minutes to do a select star from that table. Great. But if we were to do this across the cloud and across the network, that might not be the right way. It might be just select the 2 columns that you need from such table, where, put the where clause in, bring down that IO, and you're going to have less challenges. It's going to be a lot smaller IO across the network, and of course the network is our last bottleneck and get better performance. That you want to look at ingress and egress charges. Depending on those, you may want to really rethink about what you move to the cloud, not just the database, but these 2 applications. Always try to keep them interconnected. This is always important when you're trying to do this, to remove a lot of complexity. You may have some people that said, well, we had this database here, user database, or even into schemas, cross-connected, because these were all on the same server. And now we're breaking them up and only moving some to the cloud. And they go, no, you know what? These all need to go in one database, should be close connected and in availability zones. All of this information as you start to understand Azure technology to make smart decisions on what you migrate and what cloud services you bring in. So we're going to start with infrastructure around compute and VMs. So a lot of folks are going to come to me, and the first thing they're going to say is, you can't handle my workload. And the truth is that we can handle their workload. I mostly decouple Exadatas, and I find that there's only been 5 workloads of literally 1,000 or more that I have done assessments on that I haven't been able to handle. They've been on proprietary environments that have built out with huge scaled rack environments, 10, 12 nodes, they're huge. But they'll then come to me and say, can you do that on the cheap VM and the cheap disk? No, we can't. So A and B series, they look really nice. The price tag looks great on it. You probably can't run a database on that. SQL Server, Oracle, doesn't matter. Yes, Oracle may need on average, and same thing with just freestanding Postgres, larger VMs. But you will also find that you have challenges with being able to run any type of relational workloads on these. D series are good for like standard ones and development workloads. And then you'll see L and H, and you think these are massive systems with all this NVMe storage and that, but are they right for relational workloads? Probably not. So leave those all in the bin. Where you're going to center your understanding is D series SKUs and E series SKUs, and then the M series, depending on your storage. So keep this in mind as we start to look at these, and definitely download these slides that you can take this reference back and you can link on this and really get some information going forward. Are there any questions on this? I noticed somebody came off mute.
Not so far, no questions.
Cool. Now just to get my slides to go forward. There we go. And went one slide too far. So I want you to see some of the information from the Microsoft Docs. These are incredibly crucial as you're starting to size this out. And hopefully, as we go to the end, this will all come together in a nice, neat picture. So you're going to notice that you will see DS in the D and the E series that I'm choosing. And we'll talk about why that's so important. D is for your OS disk, that you can have a premium SSD for your OS disk. SQL Server as well as Oracle really needs this to get good performance for their relational workloads. S is for your ephemeral disk that's attached onto that VM. Your swap file won't be remote. It will be on the VM and will give you great performance for that image. These, again, are important. Remember, if you run out of memory and it has to swap, it's extremely crucial that this is able to do it connected to that VM, not a remote choice. So that's why I choose the DS in both the D and the E series. So you see D, DS, and whatever number of SKUs, or we'll talk about constrained as well. And then D4 or V5. And you see the V5 at the end that has stars on them. These came out at Ignite. They're really fantastic machines. Many of us on both the SQL Server and the Oracle side, we have been driving the features that you're seeing in those series. We love these, but they're coming out little by little in availability zones. So if you're like in South India or South Brazil, you probably don't have these yet. So be aware of that. But for most US regions, these are already out there and they are fantastic. They're phenomenal. And I want you to see why. So the vCPUs is a little bit higher, yes, absolutely, as we talked to 296 and 2 to 104, yes, these are higher on these, the D versus the E. The E is the workhorse for us. These are the most common ones that we use for my big Oracle workloads. Look at the throughput. And remember always, it's not IOPS. Even though you hear so much about IOPS, it's megabytes per second. Your throughput is the crucial piece. It's not the IOPS. And be aware that for the E series, they have a max of half the megabytes per second than what the V5 series has. Those V4s are limited on the throughput. Now, I want you to also notice the M series. M series are more expensive. They're the memory optimized. If you have a high memory requirement, this is where you're going to go. But then notice that limit on the megabytes per second. They have lower limit. And if you're caching, we'll talk about the value of read-only host level caching, it's going to go lower. It'll go from 2,000 to 1,000. It's the only series that does this. It's really weird. So then look in the next column to the right here, this max IP egress rate per megabytes per second on NFS and iSCSI storage. NIC attached storage will give you the best benefit. This is where we go when we go into high IO workloads that we'll talk about. Notice how high these are, and especially for the EDS v5. What we can achieve with these, I have Oracle Exadata workloads that are doing 30,000 megs per second. We can meet this. This is capable on a single VM. Be aware what this EDS v5 series brings. We usually are much more limited on the M series. So of course, we're only going to go to that M series if our workload is able to go through that. It doesn't hit that max and won't throttle. We'll talk about IO throttling, as well as looking at the actual memory requirements. Because we need more high memory, we're going to end up falling into that M series. And we're hoping, within the next couple of months, you're going to see a V3 at least on the M series to kind of fix that whole IOPS and megabytes per second limitation. So you may be, we all feel this kind of issue when we're sizing out and migrating things to the cloud. Your SQL Server as well as Oracle may be licensed by core, and there's going to be a higher core demand on the licensing if you move it to vCPU from on-prem CPU, that core licensing. So there are constrained vCPUs. I use these constantly. They're a little weird when you're looking them up in the pricing catalog as well as in the documentation. Always remember these are kind of misnamed. Folks came back from Oracle and they said, no, these are this constrained vCPU. I have to charge for all the CPU. So they were looking at these numbers that you see here, and they look like this first one, standard E4 2v5. They thought they were charging for all 4 vCPU. There are no 4 vCPU. There are 2 vCPU on here. And I did a blog post on this to prove this. It's the bigger chassis with 2 vCPU. Be aware that these are kind of misnamed. I went in with Linux commands and showed that there are only 2 vCPUs in every single Linux command that I could find to count these. There isn't 4, they're not there, you can't get to them. There's no way to enable them, so nobody can charge you for these. Be aware that these are really fancy machines. These are fantastic opportunities when somebody needs higher memory, higher throughput, more disks that they need to be able to attach. This comes in very handy, so you get that bigger chassis, but less vCPU that you have to license for. And the licensing will go on the second number here. It's the bigger chassis, so all the specs are like the bigger chassis, less vCPU. So hopefully that makes sense. Next, architect for the cloud, maximum availability architecture. There's a lot of names for this. That's the name for the Oracle side, but somebody has how they do high availability. Oracle has a real problem with this because they have oversold and marketed that thing called RAC, Real Application Clusters. It's really important to understand, again, that for the data center that you have, you can't architect what we have inside Azure. Nobody should be asking you to do that. But when you're starting to talk about the cloud and everything that's built into that for HA, just in the redundancy built at the disk level, the VM level, failover, availability zones, availability sets, this is something that's pretty astounding. So when you're bringing something in like RAC, you end up building out a lot of redundancy that makes absolutely no sense whatsoever. That people go, well, that's high availability. No, it's not. It's instance resiliency and it's scalability. and absolutely we'll look at that. But also Oracle says, if you do rack in any third-party cloud, we won't support it. So I also want supportability. So that's crucial to those solutions, and definitely look at what is the best way to build out the database platform that you're working in the cloud. There should be a recommended practices white paper. I have one for Oracle. I know there's one for SQL Server there. Utilize those. And I think even the SQL Server one is linked in this set of slides. So you need to understand location concepts, region versus availability zone, geo-region locations. We do have customers that their SLAs may be a little bit behind the times in saying that you need to be geo-region located. We like to get to availability zone located, but I do have customers that their architecture design ends up having a primary, a standby, and then a third standby sitting in another region. That's all doable, but be aware, what are their SLAs? Start talking to them about their RPO, their RTO. In other words, that recovery point objective, that recovery time objective. Find out what those are. They may not realize that they over-architected and they'd overpay for their cloud solution, or they built in redundancy where they don't need it. Definitely look at those when you're architecting a solution for them, for you. And availability sets means that we just have multiple copies of everything. Your application tiers are here. You probably hear a lot about Azure Site Recovery. That's great for your application tier. Know that it can only handle up to 100 megs per second right now. So for most relational workloads, it is not available. It doesn't work well. Even for your SQL Server workloads, there is a limit on how much it can handle. Personally, I'm a DBA. I want guarantees, and that's not going to be an option for me, and it's definitely not an option for Oracle. So how do I architect some of this? I am looking absolutely at their RPO and RTO. This is one architecture design. This is one where I am taking my availability zones, and you will notice that I have 3 availability zones. I have 2 copies of things. So I have my primary database along with my secondary database that's sitting in that 3rd availability zone. So if we're going 1, 2, 3, I know it's 0, 1, 2 and how these numbered. But the first one, I've got my primary, I've got my secondary. I don't have anything in that second one other than my observer. And my observer, its whole job is to check the heartbeat on those databases and see which one is primary. If the primary is going to fail, then it will automatically reroute everything to the secondary. And that doesn't matter if it's the primary observer or the secondary observer, it will automatically fail over everything. The application only connects to the observer, not to the database. So that is the go-to that makes this decision. So no matter what availability zone goes down, I have different things that can connect and address this. So I can also do this with 2 availability zones and then put a 3rd environment inside another region. So depending on what my customer needs, I would absolutely be able to do this. And I have a question. Can you go further to explain why you would not recommend Azure Site Recovery for database? Absolutely. The reason there has to do with the throughput. Look at your database workload for SQL Server. If you're doing in your transaction log 100 megs per second change rate on there, don't do it. Absolutely do not use Azure Site Recovery for it. You may have some issues. It is much more compatible with SQL Server than other database versions, but we have stepped away. The product managers make it absolutely clear that they will not support what they call churn, which is block changes of over 100 megs per second. So hopefully that helps. And for Oracle, none. They will not guarantee any Oracle workloads. So hopefully that answered that question. Yeah, you have to go right up to the very, very top of the Azure Site Recovery, folks. There's a lot of myths about Azure Site Recovery, and they aren't Oracle compatible at all. And for SQL Server, they'll come back and tell you that. And then use your availability zones. There is ingress egress charges for cross-region deployments. Availability zones don't have that. So if I'm trying to save on ingress egress, I absolutely am going to try to focus on availability zone deployments. You don't have that overlap in there. There's redundancy built in. This is the proper way to do a high availability environment. So definitely look at that and always try to use AZ over multi-region deployments. Any questions about availability regions, availability zones? say no. I just heard a little sound in the background, thought I'd check on it. And use DR products that best support the cloud. ASR, absolutely great for your application tier. Databases, look at your always-on availability groups. For Oracle, DataGuard. DataGuard is very similar to always-on availability groups. It is an incredibly robust product from Oracle. It is my go-to. We love it. We absolutely love it. It works seamlessly within here. If we want to even do a standby on the other side of the planet, we have far sync instances that will make sure that data is there, depending on if customers want, guaranteed performance, guaranteed availability, or guaranteed data protection. All of those options are there. It's incredibly robust. And because it is like always on availability groups, it just is really seamless. It just works so well with Azure. We also have options that we have available that is called Fast Start Failover. So if customers want to have that as their high availability solution for maximum availability architecture, customers will say, oh, I need rack. You actually need DataGuard to get above bronze level in high availability for Oracle. They read all the buzzwords. They didn't read all the words. And you find out that that's how you do it, and the secondary will automatically come up. It keeps track of it with the observer and everything. Depending on your RPO and your RTO, there's a question here. So I understand you would recommend always on AGs instead of ASR for SQL databases. It depends on your RPO and RTO. Just like when I'm dealing with DataGuard, DataGuard is my go-to. But for some of my customers that come back and they say, for this database, I can be down for 24 hours. And I have a uptime for, if my recovery point in time needs to be for 1 day, I can apply, let's say they do bulk loads. There's no they don't have to apply the logs to get back up to point in time. They can actually do bulk loads from their transactional system. They wouldn't need DataGuard. They could actually do a storage clone solution and bring that up and then load the data again, and they're up and running, and it meets their RPO, RTO. The same thing would come up for always on availability groups. Always on availability groups, let's say if a customer says, I have 15 minutes, 15 minutes with 2 hours, for my RPO, RTO. When you start getting into those real short windows, that's when you start wanting to make that decision. You have to look at the RPO, RTO to decide. But we're going to have recommended practices and different levels, I think, is what you need to go into. Critical applications versus production versus test versus QA. So ASR may meet some of your environments, and you're good. You may say, I have this one database that's a development database, and if we have just a snapshot of it, we can bring it up. Now, my concern with ASR is that it is not database compatible for Oracle. So if we recovered a database from ASR, it most likely would not come up in a consistent state. You would need to recover the database and have the archive logs and see if you can get it to come up consistently. Most of the time it won't. So that's the reason I would not use ASR with an Oracle database. SQL Server is a little bit different. So be aware of that. Hopefully that works. Hopefully that answered that question. If not, let me know if I need to go further into that. Let's see, we covered all of this. And always test, always test. I find that a lot of customers, as they migrate to the cloud, will wait to the end to test their backups, their DR, and their HR or HA. And you really should test that one of the first things. It's very surprising on this. And the reason is that a lot of backup tools are quite high-O, and they don't realize this. And so you come up with your solution, your standard workload works fine. And think of it this way, nobody wants to be the noisy neighbor in the cloud, so they make sure nobody can be the noisy neighbor. So you've added this IO, your tools come in that are backups and your maintenance jobs at night, and it throws you up to the threshold, the ceiling. And so everything kind of throttles, called IO throttling, and you can't get any more out of it. And so your backups take longer, your batch loads take longer, everything at night. And you find out that this backup solution that worked fine on-prem doesn't work as well in the cloud. So be aware that you don't have unlimited IO. Be aware of this. And that's why I showed you what those limits were for your VM. When you're calculating what you need for your workload, ensure that you include your backup and your maintenance jobs IO demands. For Oracle, they're incredibly high, and this will throw them. Sometimes it's 20 to 40% of the overall IO is on backup. So this can be really harsh on a system. So we have to look at those very closely. So then we get into storage. And I have a question. What is the recommended testing time frame? How often for ESR? We test quarterly and are constantly surprised with changes Microsoft has done to the ASR environment. Because I don't use ASR, I don't know. I mean, ASR is just a no-no for Oracle, and I do all Oracle on Azure. I would be very happy to take this question back to Pam Lohard, because I do meet with her regularly, and she has the SQL Server and VM stuff. She's like my counterpart for SQL Server and VM. So I'd be very happy to ask her that question and get back with that answer to the group. So let me do that, because she would have a better answer that would be more in line with that. So the nice thing about storage is that storage is completely separate from the compute. Like I said, megabytes per second is extremely crucial to us. We absolutely need to know that. And Oracle has demonstrated on average. Pam right now is working with Silk. I was working with Silk, 14 months ago. It was a bigger deal for me. I had, these Exadata workloads that I was trying to find solutions for. And knowing what options are out there are extremely important. Most folks are not aware of them. So what are these, workloads like? Absolutely, workload is essential. We don't talk so much about databases. We talk about workloads. OLTP, DSS, OLAP, big data versus logging and backup. All of those make a difference in what kind of storage that we choose. Now, this is a graph of what we talk about with premium SSD. We don't really use any standard SSD. It's all premium for us, and from there going up. So as you notice, you'll hear a lot about P1s through P20s, and you hear a lot about bursting. Burstable storage, I know it's beautiful. Everybody loves it on the product teams. I'm going to tell you it's not consistent. And the problem for DBAs is we want consistency. And when you talk about bursting is what is available on that shared VM. If you're doing month-end processing, guess how many other people are doing month-end processing? If you're doing nighttime bulk processing, guess how many other people are doing both month-end or nighttime bulk processing? It has a tendency to hit the same ceiling for everybody. They're all trying to burst at the same time, and you can only use it if it's available. So for us, we didn't find it in real, performance benchmarking to be usable. What I like is host level read-only caching on my data files. And that's what you're seeing in the P30 through the P50. So notice the sizes, they're 1 terabyte, 2 terabytes, 4 terabytes. Notice on the right, cache limit per disk is that it says 4,095. Now, burstable can get upwards to 1,000 megs per second. You're rarely going to get that. Like I said, it's not consistent. But with host level read-only caching, you will get 750 megs per second. It is consistent. So you go from 250 megs per second to 750 megs per second read only. Again, write through. You want to write to your data files. You don't want that caching. But the read only is incredibly immense on the performance gains that you will see with it. Notice the P50. I'm not doing the entire disk that I'm allocating. It's not 4,096. 4,095 is the upper limit on how much you can do. It will disable it automatically if you do 4,096. Just leave that last gig alone, do 4,095, and you will get 750 megs per second instead of 250. That's a big change. It is awesome, okay? Forget about the math of the burstable. It's really nice in theory, not so much in reality. Now we start talking about the P60 through P80. You need to realize you're probably going there because you have a max quantity of disks that are allowed to be attached to that VM. Some of these will say you can only have 8, and you've got, a 200 terabyte database. Well, you're going to have to go up to the P60s and realize that the throughput per disk, you're probably going to get what is there in that column, or count on the burstable and hope you're going to get it. But if you try to do the cache limit, you're going to have to give up all that extra storage that you met. So it's kind of the lesser of two evils. You have to choose what you're going to get. But if you have more throughput demands, that you need more, there are options. And I want to make this quite clear. UltraDisk, they'll talk about. They'll talk about UltraDisk till the cows come home. And I'm going to tell you, it's not that big a deal. I use UltraDisk for a very clear reason. It's not for this. And you're going to see it's complicated pricing. If you calculate it, it's very expensive. So it goes on the disk capacity, the provisioned IOPS, the throughput, and then the actual vCPU reservations chart. So depending on how many vCPU you have to calculate that in as well. This price tag can be really expensive. Where do I use it? I use it for redo logs. You'll probably want to use it for transaction logs for SQL Server. That's going to be the recommendation over and over again, not for your data files. And the reason is that you're going to only be able to use traditional backup methods, which means you have to use standard. You can't use snapshots in any way, which means you reintroduce that IO. And for me on Oracle, that's a lot. I don't want to do that. It's really, really expensive to do that. And my IO goes down to what I'm almost pretty much getting with premium SSD. A lot of limitations, and there's a lot of bugs for Oracle with the sector size. So for me, logs, excellent. Your transaction logs, your redo logs are small. You can allocate a small amount and get really good megs per second. And if you have log latency, this comes, in handy. So when you have premium SSD and you have log latency, UltraDisk, comes in really, really handy. And so what you're seeing here is you're going to be able to set the exact megs per second IOPS range by size, increment, whatever size you want, and get really good performance. So that's where redo logs and transaction logs come in handy for UltraDisk. Absolutely look at it for that. Try to keep away from allocating it for your data files. Now, they are in private preview and actually public preview for volume snapshots for this NVMe storage. That's a little bit of that, so there is an option there. Again, it's so expensive for big databases. I don't know if it makes sense when I have other options. First, we'll go back to this. I kind of covered all of this. Let me know if you have questions on cache settings. But this is host level caching. You turn this on at the VM level and then can use it for each one of the disks. It's phenomenal. Again, I make this very clear. Don't turn on read only for your data files. Make them a read, or I've tried this again, read write for your data files. You want them to write through, turn it on read only. Depending on your OS disk, read write is fine. For your logs, don't even worry about it. 4,095 is the limit on this. Verify SKU availability. This is for mostly some Ds, the Es, and the Ms, they have it. So be aware that odd one on the Ms, the number may go down. So Ms, we don't like this feature. It's a problem with the M series. You'll see it very clearly. Again, look at your documentation. Look at the tables for everything that you're looking to deploy. It makes a huge difference. When I'm deploying architecture, I actually copy and paste for the VM, what's the limitations on that storage I'm using. Put that all in so you've got it in one picture and you know exactly what you're looking at. But what do you do if you need more? And that's where we get into like ANF. You can bring in a first-party solution such as ANF, and Azure NetApp Files is really misnamed. I know that. People think it's NetApp. It's not. It is a first-party solution. This is absolutely Azure, and this is network-attached storage. So those network numbers that you saw where I was telling you those big numbers of megabytes per second that was there for per VM, this is what's using it. Azure NetApp Files can do that, and it allows us to have a data capacity pool, and that capacity pool can be used across multiple VMs and give you high megabytes per second. We're talking 4,500 megs per second. We have not tested these with the V5 yet. That's one of our next that we want to do, and I'm hoping it goes up more. But you have numbers of different scalability too. So you can do standard, premium, ultra, very similar to the names you see for premium SSD, and also be very aware as you're starting to size these that sometimes going up to the next tier will allow you to allocate less storage to get to the megabytes per second that you need. So also be aware of that. So this is just awesome, awesome stuff. Next, this is what I was talking about this. Again, only dependent on that NIC, and this is a native solution. So if people say, I need what's available in Azure, I can't use a third party. If you can use third party, this is my go-to for Exadata migrations. This is Silk. Silk uses D series and L series VMs to create out a Kubernetes data pod, and it uses the ephemeral disk on it for really, really fast I/O. This is awesome stuff. This really makes sense for all my Oracle people, but this can be used for SQL Server, Postgres, MySQL, anything. It is very, very fast. And this is completely transparent to the database. It's just presented as a storage layer, and you put your data files on there, and it runs incredibly fast. We'll talk about how fast right here. You are seeing real numbers, 12.25 gigs per second, 14 gigs per second. These happen. We are running huge epic database on SQL Server workloads. This is a huge win that's out there. I am migrating Exadata workloads left and right on this because it has compression and dedupe on it, which makes up for what I lose when I come off the Exadata. It has high I/O workloads that can handle this. It has volume snapshot technology. It has thin clones, which means if somebody wants to deploy a whole bunch of dev and test databases and they don't want to use extra storage, they can absolutely do it, and this will handle it. They can have like 30 clones of their production system, and people can work on it just like they're read and write databases, and they're not using extra storage, which is very, very helpful. Next is Accelero. This one is kind of similar, but it's using the NVMe storage, and it creates kind of a entire solution. Instead of having a VM and you attach it to the storage, this is the solution. The database, everything runs on this. It's really quick. There's InfiniBand between their H series. They have two different solutions for this. It gets very fast performance, but it's using D series and E series with an H and L series underneath it. And we use a second region, and we can use like Commvault backups or some kind of backup solution. And this thing is incredibly fast. You can get anywhere from 10,000 to upwards of 30,000 megs per second. I mean, this is massive technology when we're talking about this. This is an Oracle SE2. This is standard edition. And the way that we've built this out is just, I mean, this is fantastic stuff. I mean, this is our second one that does 3.5 gigs per second. And it's using, people love, on Oracle, love InfiniBand because, again, that goes into like Exadata solutions and that. But this could be used for Oracle. This could be used for anything. This storage is fantastic. And I have a lot of people asking about this and how we can use this elsewhere. And my slides don't seem to want to change, so I'm going to click on it. So when do you decide to go old school? Striping disks. This is old school ways of doing this. If you can, even though if you stripe disk, and I just saw this last week, I had somebody who deployed 8 UltraDisk striped, beautiful storage. And they're like, I should be getting 20,000 megs per second. And I said, you can't, your VM won't let you. You are always limited to using, or to the VM limits. Your VM calls the shots. Somebody asked, is it possible to use Veeam rather than Commvault? Absolutely. You can use Veeam, you can use Rubik, you can use anything you want inside there. I have people that use Dell backup solutions. I mean, anything you want, you can pretty much find. Look in the marketplace, look inside. You can pretty much build a backup server if you want on a VM. That's the whole cool thing about infrastructure as a service, is that you can get what you want. Yeah, my slides refuse to move. So this is my storage matrix. This is in my latest white paper, and it kind of tells you where you can go upwards to and what you have on the decision matrix to what storage you should choose. You're going to see a lot of X's marked on Silk and ANF. They're our most go-to solutions when we get into high I/O. You know, scaling options, you know, of course, you can size your UltraDisk for exactly what you need. But again, it's so expensive. Somebody told me I need to add a line with dollar signs, and I'm going to add that to this. I think that's a good idea. But I love this. I absolutely love this matrix because people have a tendency to look at a solution and they just throw it at everything. Oh, Silk should be presented everywhere. I love Silk, but no, it shouldn't be presented everywhere. It all automatically, you know, somebody's doing 100 megs per second. You don't need Silk that does 10,000 megs per second. Why pay for it? So find out what your workload is and make the right decision there. Next is failure on backups. And I know we're getting short on time, so I'll try to move through these pretty fast. You know, make sure that you know exactly what you're doing. These backups can be quite large, and they add a lot of I/O on top of the workloads that you have. Look at those and make sure that you're not hitting into I/O throttling, because it can be a real problem. And same thing, we've got this exact same thing, but also look at manage what you know. If you have a monitoring tool or something that really provides you a lot of value on-prem, realize that you can pretty much run that in the cloud. Just build a VM and put it on there. If you like Redgate software, Idera, SolarWinds, it doesn't matter. We use Oracle Enterprise Manager everywhere. There's a lot of automation built into there. It allows me to simulate a PaaS solution for Azure Infrastructure as a Service. I automate my OS patching. I automate my database patching. I monitor. I set up what we call corrective actions. So if an alert comes up, it just goes out there and fixes it with a script. Why not? Why not do that? So keep that in mind, is that you're building things that what you already use, you can incorporate into what you put in an infrastructure as a service solution and make life easier. Don't work harder, work smart. And after this here, we talked about this. So know your infrastructure, migrate workloads, not the on-prem hardware. Know the cause of your problems. If you have a performance problem also, use the same tools you did on-prem, you know, your query store, your DMVs. That data is incredibly valuable. Have a snapshot of exactly the way it performed on-prem, compare it to what is taking more time in the cloud, and address that. Don't ever assume. Assuming is probably your biggest mistake. You know what they say about assume? Absolutely. I do the same thing. While we're on Oracle, on Azure Infrastructure as a Service, we have people come back, and I'll have PMs from Alterdysk going, we don't know what the problem is. They're not even touching the disk. And I'll use my data from Oracle and say, this isn't a server problem. This isn't an Azure problem. It's just easier to point at Azure. It's actually an Oracle problem. Let me give you that information and fix that. And so this makes a really big difference. And from here, I also have a ton of references, including checklists, practices and guidelines, SQL Server and Azure VMs. This is an awesome document, very good. They're a little behind on a couple things, but this was written a couple years ago. It's excellent, though. I still recommend it. And with that, are there any questions? I'm seeing a SQL statement in here. I don't know if Gilda meant to put that in there. Let me know. But that gives us a couple minutes. That gives us 7 minutes for questions.
So team, if anyone has any questions for Kellyn, now would be the time to ask. Please put them in your chat. I know I don't have any questions, but I think I've been blown away by most of this presentation. So
I hope it's helpful. You know, a lot of us folks, like I said, we all want to go PaaS, and Microsoft would love if you go PaaS. All the cloud vendors would, but it's still in its infancy. And keep in mind that lift, shift, evolve. You don't have to stay on infrastructure as a service long term. You can start with infrastructure as a service, especially for Oracle workloads. We start looking at the schema level, what we can slice and dice off. Same thing with SQL Server. It may have to start infrastructure as a service, and as Azure SQL matures and becomes more and more robust, you can move those workloads into a PaaS solution that can handle the workload. I'm glad the session was helpful too. Thank you. Boy, you guys are going to make my life easy. Can you move Oracle running on Spark 64-bit? Very good question. Spark is pretty much one-for-one these days. It's not, those are, they were so powerful when they first started. And at this point, they're pretty much one-for-one with especially with the new Ice Lake chips that we have. We can absolutely, you're going to do a big endian to little endian conversion to go over to Linux. But we do it all the time. You can even use an emulator if you don't want to move over from that big endian to little endian. But putting an emulator like VMware on top of Azure it's just asking for problems. It's worth it just to do the big endian to little endian conversion, dump the data in, and go from there. I have a lot of customers that start out going, we're not going to change it at all. We're just going to use an emulator. And then afterwards, they're going, this thing sucks. Let's just do it. So I highly recommend just do the big endian to little endian. The conversion is pretty much one-to-one. Is there a URL for reference? You know what? I don't know. Let me see if I'll ask for that as well. Let me talk, like I said, I talk to Pam regularly. So I will ask again, see what she says about, ASR and availability groups for virtual machines for SQL Server, because I would rather get it from her. I am so inundated with Oracle and Azure Infrastructure as a Service. I handle about 80% of the Oracle workloads coming to Azure. They can't migrate off of Oracle. So my small team is just swamped. I came over here to do, I don't know if you know, analytics and AI and SQL Server. And within 4 months, I was sucked into the Oracle world. And now that's where I've been now for almost 4 years. And I think that's all the questions that I see here.
That's exactly what I was going to say. One more.
Do most of these recommendations also pertain to SQL Linux? So we did have that conversation just yesterday with Pam. They're working on some new Linux distributions for SQL. SQL Server on Linux is really the SQL Server version that I use and I run. I'm absolutely a Linux person, very deep and well loved with Linux. The SQL Server release of it, they need to break it up into more, instead of a multi-threaded process, into separate services, and it'll function much better. So I'm hoping that's where they're going to go. This would be the same key though. Your VM makes the rules. If you look at that IO workload when it's running on Windows, and let's say it's doing 2000 megs per second, you're going to need a VM that can handle 2000 megs per second, because it's not going to change. Hopefully that answers that question. Yeah, it's going to be the same though. You have to have that information. You have to have that knowledge and build out something that architects it. I do have a white paper that is customer ready. I can send that over along with my slides that tells you how to do Oracle end to end, but it has a lot of valuable data about the VMs because infrastructure is so crucial to this.
All right, so with that, I think we're good to go ahead and call it, because everyone seems to be wrapping up.
Awesome.
Answered lots of questions here. So thank you, Kellyn. This has been an awesome session, as always, from you. And everyone out there, please check back in a couple of days. We should have this site up, presentation up on our website or on DBA FunTube in the next couple of days. Be sure to check us out next week when Alpha is going to be here talking about Azure SQL Server and DevOps. So with that,
thank you, everyone.
Thank you all very much. Have a great day, and we'll see y'all next week.